Well, hello there, folks. I hope you're doing well. In this video, we're going to be talking about Chapter 7.7, Calculating Angles, and this is on page 204 of your textbook. So first of all, we'll try these. A transversal passes through a rectangle named two corresponding angles is the first thing that it wants us to do. So corresponding angles are two angles that are found on the same side of the transversal. So B and D are two corresponding angles. A and C are the other two. So angle B and angle D are corresponding angles. And then it says name two alternate exterior angles. So there are only two alternate exterior angles to choose from, A and D, because they're on opposite sides of the transversal and they're outside. They're not inside. These B and C would be my alternate interior angles. So angle A and angle D. Let's get on to some practice. Eddie cut some strips of flooring using two horizontal parallel cuts and one on a 51-degree angle. What is the measure of each angle? Explain your thinking. The first one's done for you. Angle 1 and angle 5 are 51 degrees. These angles and the 51-degree angle at the top are corresponding angles formed by a transversal and parallel lines. Let's figure out the other ones. So angle 4 right here and angle 8 are also 51 degrees. There are a few ways we know this, but one way is they are opposite. To angle 1 and angle 5. And opposite angles are going to be the same by definition. Angle 4 and angle 8. Or we could have used the same reason. They're transversals created by parallel lines, or a transversal through parallel lines, and correspond to this 51-degree angle. Whichever. Now we have, let's check out angle 2 and angle 6. So angle 2 and angle 6 are 129 degrees. We know this because they are supplementary to angle 1 and angle 5. Because this is a straight line and this one's a straight line, so these are going to add up to be 180 degrees, and 180 minus 51 gives me 129. And finally, the last two angles that we haven't talked about are angle 3 and angle 7. Angle 3 and angle 7 are also 129 degrees. We know this because they're opposite. So they are opposite to angle 2 and angle 6. So they're going to have the same measurement. And then we have an example. One example over here. The design in a rectangular floor shows many parallel and perpendicular lines. Determine the measures of the angles. Explain your thinking. First of all, what is the measure of the 8 acute angles across the top of the diagram? If you remember, an acute angle is an angle that is less than 90 degrees. So it's these guys right here. That's the 8. So since this acute angle is 60 degrees, the rest of them are also 60 degrees. And we know that because they are corresponding angles to that 60 degrees. Created by a transversal transversal transversal, and parallel lines. So in this case, our parallel lines are our angled lines, and the transversal is the top of our rectangle. What is the measure of the 8 acute angles across the bottom? Well, it is also 60 degrees, and we know that because they are alternate interior angles. So this one and this one, this one and this one, etc., etc. Oh, this last one doesn't count. 1, 2, 3, 4, 5, 6, 7. Oh, it does count. Sure, we'll call it 60 degrees. So they are alternate interior angles created by a transversal and parallel lines once again. This time our transversal is the bottom of our rectangle, and the parallel lines are still our angled lines. Finally, what is the measure of the 7 obtuse angles across the bottom? How do you know? Well, since they lie along a straight line, and the acute angles are 60 degrees, the obtuse angles must be 120 degrees, because the obtuse angles are supplementary angles to the acute angles. Or in other words, they add up to make a straight line. And that is everything for this chapter. We're done. So hopefully this is clear for you. If you have any questions, please do let me know. And yeah, you'll just have your test to do. So I hope you have a fantastic day. I will talk to you later.